Okay, in this video we will plot the amplitude and phase spectra for this Fourier series. So here we have a Fourier series of ft, and then the task is to plot the amplitude and phase spectra. Now, first of all is we have to rearrange this Fourier series in amplitude phase form, or let's just determine what is a naught, an, and bn, because we know that the general equation of Fourier series is ft a naught plus summation of an cos n omega naught t plus bn sin n omega naught t. So here where is an, a naught, and bn in this equation? So that is very important for us to determine. Now clearly from this equation we know that a naught is 1 over 2. Now what about an and bn? So here we know that this is a sine function, so this is a function, so meaning there is no cos function here, so there is no an is basically 0, so we only have this function, right? So from here we know that this n pi is n omega naught, so clearly our omega naught is pi. Now what about bn? Bn from here is consists of this whole thing, so our bn is actually 2 over pi n. All right, so we have to compare this term with this term. So clearly this bn here is consists of 2 pi as well, so you have to include this into consideration for bn. Now once we have a naught, an, bn, we can determine the amplitude and phase spectra. Okay, first of all, what is amplitude phase spectra? Amplitude is phase and phase spectra is basically a plot here. Okay, now basically this is typically the frequency, and this y-axis is the phase and the amplitude. So we have to determine the value. What is the value of an? What is the value of phi n? Alright, for us to plot this, we have to determine the capital An, amplitude an, and phi an. Now this value, okay, we can compute from the value of an square plus bn square square root. Same thing for phi n, which is taken from inverse tan, negative inverse tan of bn over an. So we have to determine an, bn first. That's why what we have done here is to determine an and bn. Right, so basically here we can plot several points, several values. So let's just assume we want to plot for 3 terms only, right? For 3 terms, meaning for n 1, 2, and 3. Okay, for n 1, 2, and 3, only for 3 terms, because we cannot plot for the whole thing until infinity, is too much. So we can only plot, let's say, up to 3, just to show that This is the phase and amplitude spectrum. Now, to calculate AN and phi n, first we determine AN and BN. So let's calculate for A1. Okay, for A1 we have to determine AN and BN, and clearly we know that AN is 0. For any n value it will be 0, so 0. Now BN, what about BN? BN, so here Bn is 2 over pi n. Alright, Bn is 2 over pi n. However, we have to carefully look at the equation. We have this term, n is equal to k minus 1. And looking at this equation, our k is from 1 to infinity. Right? So let's just write here for k 1, 2, 3, 4 until infinity, our n is 1, 3, 5, 7 until infinity. So how does this value come from? It's come from this n equals to 2k minus 1. Let me write here. So n equals to k minus 1. So here our k is from 1 until infinity. So every k value, let's say k is 1, so you have n become 1. If k is 2, your n value will become, this is 4 minus 1, become 3. So when k is 3, 6 minus 1, you get 5. So basically what you can see is there's a pattern that n value will become an odd value. 1, 3, 5, 7, it will continue. So n will become odd value only. There is no even value for n. So here, going back to this an and bn, so for the first term, n is 1, next is 3, and then 5. So for first term, for a is 1, so bn is 2 over 1 pi. 2 over 1 pi square root. So what we get here is basically 2 over pi. This is for A1. And then same thing for the angle, for the phase. -1. So Bn, we have calculated here, Bn is 2 over pi. An is 0. So when you have inverse tangent of, this is infinity, a very large value, because you divide it by 0, so you'll get 90 degree. Right, so negative 90 degree. This is for the first pi. Now once you have this value, you can plot the first line. So this is for the first one is 2 over pi, and then for the phi is negative 90 degree. So this is for the first term. Now let's work for the second term, which is an right. Now the second term is for second k, n is 3, so for a3, a n for any value is 0, so 0 square plus, now what bn? So bn is 2 over pi 3. So a3 is basically 2 over 3 pi. So how about phi 3? Same thing, because of an is 0, so this 0, this is 0, this will become infinity, large value, then inverse tan of large value or infinity will get 90 degree, so you get negative 90 degree. So now the third one, or the second term, is 2 over 3 pi. So basically this is 2 over 3 pi, and then same thing here, the third for n, right, the third n, same thing, 90 degree. So repeat the same process for the a5, get 5 pi, so, and same thing for the angle, for the face, 2 over 5 pi, you get 90 degree. So just plot it here, 2 over 5 pi, here 90 degree. Then this is your amplitude and phase spectra.